Let us start discussing S block elements. In the S block elements, two groups are there, alkali metals and alkaline earth metals. Now we will go for alkali metals. This alkali metals word is coined from which means Arabic word. The Arabic word is called ALQIS. The Arabic word is ALQIS. All Q's. What is the meaning of this one in the sense? This meaning is plant ashes. This meaning is plant ashes. This meaning is plant ashes. What is the meaning of plant ash? Why they said this one, this word for alkali metals? Plant ash is particularly rich in the carbonates of sodium and potassium. Sodium, potassium, carbonates is rich in plant ashes. Therefore, the word alkali metals is given for these metals: lithium, sodium, potassium, rubidium, cesium, francium. For these elements, alkali metals word is given from the Arabic word alquis. Alquis means plant ashes. Plant ashes particularly rich of carbonates of sodium and potassium. That's why the name is given for these metals as alkali metals. Sir. Now we will see electronic configuration of alkali metals. We will see lithium atomic number 3. Therefore, electronic configuration is helium 2s1. Next, sodium atomic number 11. Electronic configuration is neon 3s1. Then potassium atomic number is 19. The configuration is argon 4s1. Then rubidium. This atomic number is 37. Configuration is krypton 5s1. Then cesium atomic number 55. Configuration is xenon 6s1. Next, francium we will take. Francium 87. This configuration is radon 7s1. Radon 7s1. Electronic configuration is like this. Now, how the atomic radius will be there down the group? Atomic radius depends on which factors? One is nuclear charge. Next one is screening effect. Next one is number of shells. Next one is effective nuclear charge. Atomic radius depends on these factors. Sir, how these factors will affect atomic radius? Nuclear charge means charge of nucleus. Nuclear charge increases means atomic radius decreases. Screening effect is measured by screening constant that increases means atomic radius increases. Effective nuclear charge that is equal to nuclear charge minus screening constant that is increasing means radius atomic radius decreasing. Number of shells increases means atomic radius increases. So atomic radius depend on these factors. Down the group, what is the dominant factor? Down the group, dominant factor is number of shells. Number of shells increases down the group, therefore atomic radius increases. Down the group, this is the dominant factor. Okay. So down the group, you see number of shells. You see in lithium 2 shells are there, sodium 3 shells, potassium 4 shells, rubidium 5 shells, cesium 6 shells. Therefore, down the group, number of shells filled with electrons increases. Therefore, atomic radius increases. So, down the group, atomic radius increases. What experiment says that we will see. Experimental analysis says that atomic radius of lithium is 152 picometer, sodium 186 picometer, potassium 227, rubidium 248, cesium 265. So, down the group, atomic radius increases. Down the group, number of shells increases, therefore atomic radius increases, we said. As per that only experimental fact also there. Sorry. Next we will see ionic radius. We will see it is atomic radius. Now we will see ionic radius, m plus ionic radius. Why m plus? Because alkali metals will show +1 oxidation state. Alkali metals will show +1 oxidation state. Alkali metals are showing +1 oxidation state. Now we will see ionic radius. Ionic radius we will see. The ionic radius in now Li plus. Li plus configuration is helium configuration. Na plus configuration is neon configuration. K plus configuration is argon configuration. Rb plus configuration is krypton configuration. Cesium plus configuration is xenon configuration. Now, down the group of noble gases, number of shells increases. Therefore, atomic radius of noble gases increases. Like that, ionic radius also increasing. Ionic radius of alkali metal ions also increasing, we are seeing. Okay. So, ionic radius of Li plus we will see, that is 76 picometer. Sodium 102 picometer. Potassium 138 picometer. Rubidium 152 picometer. Cesium 167 picometer. So, ionic radius down the group increases. It is as per expectation. Okay. Now, atomic radius and cationic radius, that we will see. Lithium ion is the cation. That radius you see, it's a parent atom radius you see. Lithium ion radius is 76 picometer. Lithium cation radius is 76 picometer. Lithium parent atom radius is 152 picometer. Lithium cation radius is smaller than this lithium parent atom. Why? Because in lithium atom, two shells are there. In lithium ion, only one shell is there. Number of shells is more here. Number of shells is less here. Therefore, here radius is more. Here radius is less. Sir. Then we'll see density of alkali metals. We'll see in the periodic table. Along each period, which is larger in size. Along each period, which atom is larger inside? This alkali metal atom. The first atom is larger in size. Therefore, how the density will be there of alkali metals when compared to others? How the density will be there for alkali metals when compared to others? Lithium will take, sodium, potassium, rubidium, cesium we have taken. Alkali metals we have taken. How the density of these elements will be there? That we'll see. Density of lithium is 0.53 gram per cc. That means less than water. Density of lithium is less than that of water. These alkali metals we are storing in kerosene. Why we are storing in kerosene? In the sense, these are quite reactive with atmospheric air, quite reactive with water. Therefore, these alkali metals are stored in kerosene. But lithium is not stored in kerosene because it is floating over kerosene. Now, kerosene and water we'll see. Kerosene is less denser than water. Kerosene is less denser than water. Now, lithium is floating over kerosene, in the sense, how the density of lithium will be there. See. Lithium density is lesser than kerosene. So, lithium is stored in a paraffin wax. So, lithium density is 0.53 gram per cc. Then sodium 0.97. Potassium 0.86. Rubidium 1.53. Cesium 1.9. How the density is there? The density of alkali metals are low. Why density of alkali metals are low? In the sense, in each period, this element, this particular element, this particular alkali metal is larger in size. In the second period, lithium size is higher. In third period, sodium size is higher. In fourth period, potassium size is higher, like this. So, because of larger in size, the alkali metals have low density. So, alkali metals density is low when compared to other elements because of larger in size. Sir. Down the group, what happens to the density? Down the group, what happens to the mass of these atoms? lithium atomic mass 7, sodium atomic mass 23, potassium 39. That means down the group mass number increases, atomic mass increases down the group. So down the group, what happens to the mass in the sense atomic mass increases. Similarly, volume increases. Volume also increases because the number of shells increasing, radius increasing, therefore volume of atom also increases. Now density means mass per unit volume. Mass per unit volume. That mass per unit volume, what happens? That is called density. So down the group density increases. Therefore mass per unit volume increases. Therefore mass is the dominant factor. Where exception is at potassium. Exception is at potassium. Down the group density increases, we are saying. Down the group density increases. Mass per unit volume increases. Atomic mass is the dominant factor down the group. In that exception is at potassium. Why is it so? Why here exception is there? That we will see. Now we will see the atomic radius. In the atomic radius, if you see, sodium and lithium difference we will see. Sodium and lithium difference 34. Then sodium and potassium difference we will see 1, 4. Sodium and potassium difference we have seen. Then rubidium and potassium we will see difference 1, 2. Cesium and rubidium difference we will see here 7, 1. Difference is this much. Where difference is large? Sodium to potassium. Therefore, sodium to potassium, what is the dominant factor means? Increase in volume. Increase in volume is a dominant factor, therefore density decreases. Here density decreases because increase in volume is a dominant factor. Increase in volume is a dominant factor, therefore density decreases. So it is exceptional case. Alkali metals down the group density increases. At where exception in the sense at potassium. Sodium to potassium density, what happens means it decreases because of increase in volume is a dominant factor. So from sodium to potassium volume increases to large extent. In the alkali metals we have seen where increase in volume is large extent, you see lithium to sodium you see 34 is the rise. Potassium to rubidium you see 21 is the increasing. Rubidium to cesium you see 17 is the increasing. But sodium to potassium you see 41 rise. Rise is 41. But sodium to potassium if you see 41 is the rise. So where increase in volume is much more? From sodium to potassium. Sodium to potassium rise in volume is much more. Sodium to potassium rise in volume we can see much more we can see. Sodium to potassium. Therefore, density decreases from sodium to potassium. Density decreases from sodium to potassium we can say. So how the density is there we have seen. So down the group density increases, but from sodium to potassium density decreases. Okay. So density of alkali metals, how it is there that we have seen. Next we will see melting points we will see, and boiling points we will see. Sodium metal is used in the laboratory in the higher classes. That sodium metal is used in the laboratory for organic radicals determination. Organic compounds contains elements. To determine those elements, sodium is used in the Lassignas test, for which how the sodium will be given in the sense sodium metal piece will be purchased from the industry. In the lab, that sodium metal piece will be placed in the kerosene. spatula will be taken. Using the spatula, the sodium metal piece will be cut into small pieces. That small piece we will add into the fusion tube. Small pieces. That means sodium metal can be, we can cut the sodium metal using knife, ordinary knife, like that potassium. Therefore, alkali metals, how it is there, you think it. Shall we say alkali metals are soft or hard? What shall we say? Alkali metals, shall we say soft or hard? It is soft. Therefore, only we are able to cut alkali metals with a knife. So, alkali metals are soft. Soft in the sense how the melting and boiling points will be there, you think? Do you think that melting and boiling points will be low or high? Since it is soft in nature, melting point automatically will be low. Then boiling point also will be low. So that we are saying alkali metals will have low melting point because of softness, because they are soft. Down the group, what happens to the softness? Down the group, what happens to the softness, and how melting and boiling points will be there in the, that will, we will continue in the next class. We will continue.